Geometry lesson, angles formed by intersecting lines. All right, guys, we have a warm-up, but we'll be doing that in class. I do encourage you to look through it, but we'll be doing that as a warm-up in class, so you don't have to deal with this right now. Okay, here's a lesson, guys. The first lesson of this, the angle created by a intersection, is something we call vertical angle theorem. If you look, what do you notice, right? I mean, you could tell visually that angle 1 and 3 appears to be the same, and the 2 and 4 appears to be the same, no matter what kind of line you draw. For example, what if I did this right here, guys? I just draw a line like this and like this. See these two right here? They look about the same, doesn't it? Because they are, and we're going to prove that right now. Okay, so we're going to prove, let's say, angle 1 and 3. Let's prove this part, right? And then for the similar fashion, you could prove 2 and 4. Okay, so we're going to prove angle 1 and 3 are the same. But before we begin, what do we know about angle 1 and 2? Right, as in the past that we've learned, measure of angle 1 plus the measure of angle 2 is 180 degrees. And we know that the angle 3 and angle 2, when you add them up, is also 180 degrees because they are linear pair. Now, instead of writing it this way, if we instead move this right here, and then just simply say linear pair, like this, and draw a line, thus, this will be like a T-chart, right? It'll be two-column proof. These are the statements, and these are the reasons. Step number 1, step number 2, and step number 2 is a ditto, same as before. Now, have you noticed that both of these add up to 180 degrees? Yes, it does. Then you can set it equal to each other, right? Measure of 1 plus measure of 2 has to equal to measure of 3 plus measure of 2, right? And that is because it's a substitution. Some of you may want to say that this is a transitive property, and I'll be okay with that. Well, you can argue both ways because what is equal to 180? In its place, we put an equivalent value to that. Well, that's a substitution. However, it's transitive property because this is equal to something that is equal to something else. For example, A is equal to B equal to C, then A must be equal to C, right? So that's the A, B, and that's a C. Okay. At this point, what do you notice about this relationship? That's right. 2 is equal to each other. If you take it away, what do we have remaining? Measure of angle 1 is equal to measure of angle 3, and that is by subtraction property. Of equality. Okay, so that's it, guys. That is the proof, right? And then angle 2 and 4 are the same for the same reason. So this is now called vertical angle theorem, and we'll be using them quite often. Now that we know that, let us apply this idea. What is equal to angle 6 by looking at the picture here, guys? If you said angle 6 is equal to 146, what would be the reason? Right, by vertical angle theorem. You could say vert angle theorem. That'll be fine. How about angle 5? What do you think? Right, if you're thinking, hey, Mr. Yim, that makes a straight line right here, and these two has set up to 180 because of a linear pair. Then if you're thinking that, you'll be absolutely correct, right? Instead of just giving me the answer, you should be able to give me a good argument for that. And you subtract 146 from both sides. Oops, I should say a linear pair, right? And the measure of angle 5, if you subtract 146 from both sides, is 34 degrees, right? So those are the answers, guys. All right. And then this is a reminder that the complementary angle are two angles whose measures have sum of 90. Supplementary is when two angles add up to 180 degrees. So the two angles that form a linear pair are supplementary. That's right. That's why the linear pair adds up to 180 degrees. Let's look at example number 2. Okay, using this graph right here, guys. Use the diagram to the right to find the missing angle and explain your reasoning. Find the measure of AFC. AFC. The reason? That's right. If you said measure of AFC is 90 by linear pair, you will be correct because this is a straight line and that right there is 90 degrees. So the remaining must be 90, right? Hence linear pair. How about AFB, right? Well, that'll be complementary angles, right? So measure of AFB plus the measure of angle BFC is 90 degrees because those two angles are complementary angles, right? And we know that BFC is given to us 50 degrees, right? Like this. Solving for measure of AFB, it's 40 degrees, right? So that's part 1, part 2. Here and here. And this that you see over here, guys, that should have been written, that's in the wrong place actually. That should have been an angle AFE, okay? Yeah, I can see why that happened because this should have been like a little bit to the left. Okay, so let me erase this just a tiny bit. There you go. Okay, let's deal with the next question. What is the measure of DFE? That is DFE. Is that the same as this, right? And we just found that to be 40 degrees, right? So this has to be also 40 degrees. What's the reason? Vertical angles, right? So the way you write that actually is measure of DFE is equal to the angle on the other side, right? Which is angle AFB, which is equal to 40, okay? That's the progression of the argument that I like to see. And when you write it this way, it helps you to build your ability to make good proofs, okay? Do good proof questions later on, that because you could explain what you're doing, right? That's a big deal. And the key to vertical angles are that you create an X shape. See this right here, guys? X shape this way, or two V's, hence vertical angles, two V's, vertical angles, right? So these two are the same. All right, AFE. AFE is over here, and then we know that this angle and this angle is, that's right, linear pair, right? So we have to write that out. Measure of AFE plus the measure of DFE is equal to 180 because of linear pair. Sorry, I'm writing kind of small. Okay, let me pull that out and continue on. Linear pair. And we know that the DFE is 40 degrees, right? DFE is 40. So we substitute that value. Measure of AFE, therefore, has to be 140 degrees. Okay? All right, guys. So that is it for the lesson on this page. So what I want you to do is take a moment to work on your turn, pause the video, and it should take you about, I don't know, about 5 minutes or so. Okay. All right, guys, now that you're back, here are the answers. I'll quickly walk you through the answers. Number 6, that is the case because if these two have vertical angles, they're equal to each other. You would literally write down vertical angles are congruent. So when they're congruent means that they have the same measurement, right? So you set it equal to each other. And when you solve for that algebraically, x becomes 18. And number 7. And the two vertical angles are given for the same reason, you set them equal to each other. So x is 10. However, this is asking you to find each angle. So you plug the values into each one of them. Add 10 into this, 13. Add 10 into this, that's 20 minus 7, which is also 13. So we're good. Here it goes. So the bottom two questions. So basically the way you write the complement of angle, right? Angle is x and its complement is 90 minus x. You need to memorize that. And then you have an angle and supplement of angle. Whoopsie guys. That really should say of. My apologies. And the supplement of the angle is 180 minus x, right? So we should know that. So the angle is equal sign, the measure of the angle is x. So x is equal to the measure of its complement. So complement is 90 minus x. When you solve for that, x is 45. Plug it back into 90 minus x, which is 45, and they both add up to 90. Yep, they're complements. So 45s are complements of each other. Okay. The angle is x is twice. You double that, the measure of supplement, which is 180. Quantity, right? And working that out, x turns out to be 120. So this is what this is showing to you guys, is that the angle x, and then that is 180 minus x. So this thing is twice this value, and that's what I did. So x turns out to be 120. Plug that 120 here, that's 60 degrees. It add up to 180, and 60 is half of the other one, so that's good. Okay? All right, guys, that is your turn. But today's lesson contains two. Actually, this book doesn't call it a section, but these lessons are very, very small. So this will be equal to a section, right? So we're going to be talking about. We talked about the vertical angles and how to find the angles, right? So that we can talk about this right here: transversals and parallel lines. Here we go. You guys ready? All right, so we're going to be going through some definitions here. So what we have is a transversal, trans, across, verse. A verse of poetry is a line of poetry, right? The transverse is crossing lines, right? So transversal is a line that intersects two coplanar lines at two different points. That's right. It's a line that crosses different lines across the lines right here. So that is a transversal right here. It's crossing two different lines. All right. So the name of the coplanar lines in figure 1. Well, in this case, coplanar means that all three lines, for example, could be laying on the table, right? So that's why they coplanar, right? So it'll be line P, and it'll be line Q, and line T. Transversal is also a line, right? So now name the transversal over here, which is the line that's crossing two other lines. That's right. That is line T is transversal. Transversal, trans means across. Verse is a line. You're crossing the line. Okay. Now let's talk about a very important angle. We're going to be talking about this for the rest of the year. Corresponding angle. Corresponding angle lies on the same side of transversal and on the same side of the intersected lines. Now when you put it that way, it sounds a bit confusing, right? So I'm going to do it this way. So let's say corresponding angle. So let's say you have a line, let's say, right? Go a line like this. So it's on the same side of the transversal, which means that the same side this way. And the same side of the intersected lines. So when you got these lines here, that'll be on bottom side. So for an example of that is this angle and at this angle, right? And that creates this shape. This angle and this. And that creates an F shape, doesn't it? Right? Yeah, so it's an F shape. So in this case, way that we should categorize this, like now I should name the angles from figure 1, but let's just give it a name. Whatever's in between the two lines, let's call that interior line. Interior of the two lines, and over here is the exterior, and that here is also the exterior of the two lines, right? Okay, that being said, we know that the corresponding angle, okay, here's another way to think about this. Co-respond is responding in the same way. So if you have angle like here, you got 1, 2, 3, 4, and then here you got 1, 2, 5, 6, 7, 8. In clockwise fashion, like this. So for example, angle 1 is top left, and angle 5 is also top left of the intersection, isn't it? Right, that's the way you look at it. It's in the same relative position. So angle 1 and 5 are the two corresponding angles. Can you name the other three? If you said angle 2 and angle 6, angle 3 paired with angle 7, and angle 4 and an angle 8, you'll be absolutely right. Absolutely right. Once again, if you look at 4, that's bottom left. So is 8 of the intersections right here, right? That's how you tell. It's in the same relative position. How about the same side interior angle? In a different book, they might even say same side interior angle. They might call this co-interior angles. Lie on the same side of the transversal and between the intersecting lines. So in that case, we may have something like this. Same side of the transversal, so it's in either this side or this side, but they're interior. So we're talking about this angle and this angle. So it creates a C shape, doesn't it? That's the shape of the C. If that's the case, what are the angles does it create? What are the angles that could be represented in the figure 1? If you said angle 4 and 5, you're absolutely right. Semicolon. And how about, yeah, angle 3 and 6. Okay, so it creates a C shape this way, right? And the backwards C shape right there. All right, how about alternate interior angles? Are the non-adjacent angles that lie in the opposite side of the transversal between the intersecting lines? Yeah, that could be kind of hard to think what it might mean. So if you had a line this way, it's an alternate side that's not adjacent. So it's not this and this. No. It's this and this. So we're talking about this shape right there. And that seems to create either a Z or an N shape. You know, if you rotate a Z, it's N shape, isn't it? Right. So if that's the case, where do you find them? It's this one, isn't it? And this one. Right. So if you set angle 4 and 6 and angle 5 and 3, you'll be absolutely correct. How about the alternate exterior angles? Yep. So if you have this, you make it's in the opposite side. So if it's here and it's in the alternate side, so it has to be on this side, but it can't be the one that is adjacent, right? So it has to be this one. What shape is this? I don't know. It could be two V shapes, I suppose, right? All right. So in that particular case, yeah, I don't look at the shape for this one. Let's call it two V's, okay? In this particular case, it'll be 1 and 7, okay? It'll be this one and this one, because they're both outside, but on the opposite side, right? Alternating side, that's right. And angle 2 and 8. If that's the case, You might be wondering, hey, Mr. Yim, is there like same side exterior angle? Yeah, actually there is. This book doesn't really mention it, and later on it uses that idea. These angles are exactly what you think it is. So if you have this shape, it's in the same side exterior. All right, same side. When I say same side of the transversal. So in that case, it will be angle 1 and 8 and angle 2 and 7. Okay, guys. All right. So that's the basics of it. We're just learning how to name stuff. In this particular case, let's say P and Q are coplanar lines and are parallel. So we're talking about a very special case right now. Before, P and Q, right here, was not necessarily parallel. In this case, it is. If that's the case, let's forget about this for now. Let's focus on this. Wait a minute. Do you notice anything? Obviously, these two are the same, right? And we know that these two are the same because they're vertical angles, right? But 2 and 3 are supplementary. We know that. But what do you notice about angle 2 and 6? Do they appear? They appear to be. If you're saying 2 and 6 look like they're congruent, you're absolutely positively right. Okay. So this book decided that they're going to call it a postulate. Postulate is something that is so obvious that you don't have to prove it. It's given truth. All right. So same side. So according to the same side interior angle postulate, two parallel lines cut by transversal, then the pair of the same side interior angles are supplementary. I'm going to allow you to use a shorthand for this. Parallel lines implies that the same side int angles sub. So I'm going to let you be able to write those sort of like a shorthand if you want. That being said, let's identify the same side interior angles in this case. If you said 3 and 6 or angle 4 and 5, you'd be correct. What is the sum of the angles? Well, you just told us, right? 180 degrees. If angle 6 is 70, find 3. Now, you could tell me it's 110 right away, but I'm really not interested in that, right? I'm sure you could do that in your head, but I'm more interested in your ability to just, have a good starting point and have a good end point and be able to demonstrate what you know using the language of mathematics. Okay? So we're giving you information about 6 and we want you to find 3. So we need to find the relationship between 3 and a 6. What is 3 and a 6? That's right, it's same side interior angle, right? So we know that the measure of 3 plus measure of 6 are co-interior angles or same side interior angles are what? Supplementary, because we got parallel lines, right? I just wrote it over again. So that's the theorem, right? And the postulate, and that's 180. And then we know that the angle 6 is 70. That's a substitution, right? Subtract 70 from both sides. That is 110. So that is the step that I was looking for you to show me. Okay, guys? All right. Yeah. We're almost done. Okay. So let's do a little proof, shall we? So this is a guided proof in a way, right? So this is the alternate interior angle theorem. So whenever we're doing a theorem, we're supposed to be able to prove it, but you're allowed to use the previous definitions, postulates, anything, previous theorems, to prove the current one. Okay, we're building on top of the pyramid, right? So we're creating a pyramid, right? All right, guys. This theorem that we're trying to prove says is alternate interior angle theorem. If two parallel lines are cut by transversal, right? Whenever that says that, I'll allow you to just write it this way. Then the pair of the alternate interior angles are congruent, also have the same measure. So you could say alt interior angles congruent. Or simply stated as alternate interior angle theorem, right? So here it is, guys. We're given that P and Q are parallel. There you go. And now we're supposed to prove 3 and 5 are congruent. So what would you put in number 1? If you said given, that is correct. I wouldn't cross it off. I'll just put a check mark. Because sometimes you could put a check mark. I'm sorry. You could use same reason more than once, right? So 3 and 6 are supplementary. 3 and 6. What is 3 and 6? The same set interior. Oh. Do you have the same thing that I do? Right? It's this one. Right? So you could literally write down same side, interior, angle, postulate. Okay, check. But they're equal to 180. Hold on a second. Isn't anything that's supplementary 180 degrees? Oh, okay. That must be the definition of supplementary angles. So you write down definition of supplementary angles. 5 and 6 are linear pairs. Are they? Yeah. According to linear pair theorem, right? They're adjacent angles whose non-overlapping sides, non-adjacent side forms a line. Good. So this is a linear pair theorem. Okay. And according to linear pair theorem, the linear pairs are supplementary. Oh, that's the theorem. I see. So I just made a mistake, didn't I? Right? So this thing actually didn't have it. So that right there, to say that linear pair is a supplementary is to say what? That is the theorem. So I wonder what number 4 is then. Right, it doesn't say it here. It's not one of the choices because if you notice, we got 2 of the same thing. So I must have had a typo. So that should have been definition of linear pair. Okay. And now when supplementary angles are 180, that is what, guys? It is a definition of supplementary angles right there. Copy, paste. There you go. And well, what do we have over here? Ooh, where do we get this? Well, as it turns out, those two things are both 180 degrees, so you could use substitution property, subs prop of equality. Check. And 3 and 5 are the same. It's a subtraction property. Oh, you know what? I have bad eyes, don't I? Right. That's a subtraction property. Subtraction property of equality. My apologies, guys. I think I just forgot to put the definition of linear pair. Okay. All right. We are almost done. We need to do 2 more, right? We just did the postulate. We did 1 theorem, and if you remember, there are a total of 4 of them, right? This will be quick, hopefully. Now, alternate interior angle theorem says if 2 parallel lines are cut by a transversal, then pair of alternate interior angles are the same measure, right? So alternate interior angle 3 and 5 and 4 and 6 are the same. Okay. All right. So why do you think that is? Right? And then we got corresponding angle theorem says the corresponding angles are congruent. Why do you think that is? Okay. So here it is, quickly. Why does 1, 3, and 5, 7 have the same measure? Because they're vertical angles, right? These 2 and these 2 are the same, right? Because of vertical angles. Angle 1 is congruent to angle 3, comma, angle 5 is congruent to angle 7 by vertical angle theorem. But we know that according to what we just learned, alternate interior angle, measure 3 is congruent to a measure of 5 by alternate interior angle theorem. If these two are the same, then 1 and 7 is the same, isn't it? Because of that, they all have to be equal to each other, right? You all see that? So angle 1 is congruent to angle 3 because of the vertical angle theorem. 3 and 5 are congruent because of the alternate interior, and 5 and 7 are congruent because of vertical angle. So from here to here was a vertical angle. From here to here was a vertical angle. And from here to here was alternate interior angle theorem. For that reason, 1 and 7 are congruent. Sounds good? All right, guys. So how about 6 and 4? Yep. We know that by alternate interior angle theorem, angle 4 is congruent to angle 6. So what that means is that measure of 4 has to equal to measure of 6, which is 75. Therefore, the angle 4 has to be 75. Just really quickly, guys. When these two are parallel, we know that these two angles are the same. By alternate interior angle, 4 and 6 are the same, and these two are the same. And we also know that this over here are congruent for the same reasons, same exact reasons. And the pink and the blue dot adds up to 180, right? So yeah, that's right. That's the easy way to remember this thing. So we know that 3 and 6, which is co-interior angles, has to be supplementary. That also means that same side exterior angle has to be supplementary. And alternate exterior like this has to be congruent. Just by making this little picture of you guys, you could sort of remember all the theorems and which is supplementary and which is congruent. Okay, guys? All right, guys. Last bit. I promise, this is the last theorem. Okay? All right, guys. So we're trying to prove that corresponding angles are, corresponding angle theorem. If two parallel lines are cut by transversal, then the pair of the corresponding angles have the same measure. Okay. We actually need this picture up there, so why don't I just copy it over? That's P and a Q, right? And the T is over here. And that is 1, 2, 3, 4. And then we got 5, 6, 7, 8. We know that these 4 and 5 are alternate interior. Yep, 7 and 8 are congruent. Whereas, let's go with, what goes well with pink? Everything goes well with pink. But in this case, let's go green. 2 and 3 and 6 and 8 are the same for the same reasons. And the pink and green are supplement to each other, right? So we're trying to prove 3 and 7. Okay, we know that angle 4 and 6, according to this form. Did I mess up? Oh, I did. So that should have been 1, 2, 3, 4 right there. Oh, silly me. All right, so angle 4 and 6 are supposed to be a pair of alternate interior angles, right? Alternate interior angles. So they're using alternate interior angle theorem. We know that the measure of 4 and 6 are equal to each other, or you could say that they're congruent to each other, right? I'm okay with either one. Some teachers and some books are really strict about which one you use, but I'm kind of, going to save us a couple of steps there. 6 and 8 form a vertical angles. So by saying the vertical angle theorem, we know that the 6 and 8 are the same. That's right. But think about this for a second. Using this information and this information. All right, let me use a different color. Measure of 4 is equal to measure of 6, but 6 is equal to measure of 8. Jumping across. Transitive, right? But the book, I believe, also uses it as a substitution property. I could see that argument because when you replace 6 with its equal value, which is 8, 4 and 8 are equal to each other. So in this particular case, substitution or transitive property I'll take both of them. Okay. So using substitution property of equality, or just you could say transitive property, right? Of equality. In 4 and 6, we substitute for measure of angle 8 for 6, and the result is that measure of 4 is equal to the measure of angle 8. That's it, guys. That's how we prove it. All right. Okay, guys. So we are actually done with the lesson presentation, but I got 2 copies of that. All right, there's a U-turn, guys. I want you to pause the video, spend about 2 minutes on it. Okay. My intonation should have been down, but it was kind of up. So if you didn't pause the video now. Okay, guys. All right, so what did you get for the answer? This is what I have. Okay. So we know that if these two are parallel, right, this and this is the same. Yeah? And we know that's 126. So what we have over here is that 12x plus 2y, this right here, plus 126, oh, sorry, this angle and this angle are corresponding angles, right? Because these are parallel. So according to this intersection, they're in the same position, right? Upper left corner. So they're equal to each other. So 12x plus 2y equals 126. And we know that this right here and this right here makes a Z shape. And there are 36 in this. They're equal to each other by alternate interior angles, right? Right. If I subtract the 2 equations, the 2y's cancel. 12 minus 3 is 9x. 126 minus 36 is 90. Divide by 2 to both sides. 9 to both sides. X is 10. So plugging into the equation, either one, you'll find that y is equal to 3. Okay, guys? All right, guys. This is one of the longer videos. I apologize. All right, I'll see you in class. Bye-bye.